Good morning, everyone. Welcome to the webinar today of AS1670 Part 1, 2018 edition, the most important changes. My name is Carol. I look after marketing communication for fire business in Australia and New Zealand. With me today is our subject matter expert, Keith Sheen. Many of you might already know Keith. He has been in industry for more than 20 years. He's our Honeywell industry fair leaders. And in today's session, Keith will be discussing the overview of these key changes in AS1670 Part 1 2018 edition and their implications for fire system design and installations. This webinar will be recorded and scheduled to last 45 minutes with a live Q&A 15 minutes afterwards. So you will hear from Keith shortly, but first, I'd just like to quickly run a housekeeping introduction video to those who hasn't been into this platform before. Here you go.
Make sure you've got your speakers or headset on and volume up. If you're experiencing technical issues, try refreshing your screen by pressing F5 on a PC or Command-R on a Mac. The console on your screen is an interactive tool that enables you to organize the content the way you want to see it. The webinar slides will be displayed in this window. You can participate by submitting questions in the Q&A widget. We hope you'll have lots of great questions for us. To the right, we've got speaker bios where you can learn a bit more about us. If you want to also download today's presentation, plus a whole host of really great supplementary material, you'll see a resource centre under the bios. Go ahead and download that content. All of these widgets are resizable and movable, so you can shift things around to get the most out of this session. Moving on to the buttons right at the bottom. The first one takes you to the Help Centre, where you can troubleshoot and view frequently asked questions. The next 5 buttons open the console widgets again, if you close them. The remaining buttons are for social sharing. You can share links to the live session now or the on-demand version later. The on-demand version of this webcast will be available shortly after the webcast via your access link. Feel free to spread the word. I recommend a wired connection and that you close all of your open windows and apps. This will ensure that you've got the optimal bandwidth to get the best experience out of this. Finally, I hope you've got a coffee in front of you, so sit back and enjoy.
All right, I hope you get your coffee ready. So yeah, I see a lot of people start jumping on we're ready to join the webinar. So before I bring Keith back to the stage, let's just run a quick practice to make sure we actually know these features for Q&A. Can you please tell me which state are you from? Can you put your answer into this Q&A box? Yeah, the purpose of doing that is because unlike Teams meeting or Zoom meeting, this On24 platform, we can't just unmute ourselves and speak up. The way we ask questions during the webinar and end webinar is through this Q&A box. Let's see. Oh, awesome. I got the answer coming here already. Wow, I have Jason from New South Wales. Hi, Jason. How are you? And David from Victoria. Hi, David. Thanks for joining. Oh, Brian from South Australia. Hi, Brian. How are you? And Anthony from Victoria. Well, I got a lot of them respond back to me. Oh, that's awesome. Seems like we're on the same page. So yeah, there will be a 15 minutes Q&A as time after the webinar. Let's make most out of it. So if you see any question that you want to ask during the webinar or after, please use that chat box here. Okay, with that, I'm pleased to introduce our presenter today, Keith. Keith, please take it away.
Okay, thanks very much, Carol. So today we're going to discuss some changes to 1670 and focusing on transmission paths, isolators and networks. Just a quick introduction. I'm Keith Sheen, the Industry Affairs Leader for Honeywell. I'm a member of FP2, have been for many years, the convener of this working group for 1670. I'm chair of ISO TC21 SC3, which is the equivalent of FP2, and of course SC3 is responsible for writing most of the ISO 7240 standards, which we've adopted in recent years. And I'm also a member of the FPAA TAC 1 and 2 fire committees. So the key elements we're going to discuss today are transmission paths. the use of transmission path isolators, and some practical example of transmission path design focusing on detection, power transmission, and audio. And we'll also look at networks and remote access to FDCIE. So in terms of the change to ISO, 1670 has really adopted this concept of a transmission path. So everything that connects the different components within a fire detection and alarm system is now called a transmission path. So the definition of a transmission path is a connection, and it's important that it's external to the cabinet. So once it enters the cabinet, it's not considered a transmission path anymore, between parts of the FDAS for transmission of information or power. And examples are electrical cables, fibre optic. It could be electromagnetic radiation, radio, microwave, or infrared light. So any form of transmission of information or power is called a transmission path. So one of the things that we've set out to do was to really set consistent requirements to make it easier to determine what could be affected by a fault in a transmission path. And the limitation applies anywhere within an FDAS. So whether the transmission path is between distributed CIE or networked FDCIE, detectors or alarm devices such as sounders or speakers, the same requirements would apply. And clause 2.6 in 1670 sets out what can be lost by a fault in a transmission path. So a single transmission path fault shall not directly affect more than one of the following: a detection zone, the indication of a detection zone at the designated building entry point, which is the point where the fire brigade will enter a building to access the FDCIE. Similarly, at the one building alarm indication at the designated site entry point. So that would be, if you've got Holsworthy Army Base or a university campus where there's a main panel and then all the buildings are connected to that main panel. D, one area of occupant warning covering not more than one level or more than 2,000 square metres. So an important change was made in 2018 to limit what could be lost by a fault in a transmission path. Previously, it was acceptable if you had a 4-storey building, you could have one transmission path, one cable leaving the FDCIE, looping around to all the speakers or sounders on a 4-storey building. If you had an open or a short circuit somewhere, if you had a short circuit, you could lose the whole building, and no alarms, no occupant warning would be enunciated. So now the change is that you need to take a separate transmission path as a feed to each floor. So if you lose one, if there was a fault on one floor, the other 3 floors in the 4-storey building would continue to operate. That doesn't mean it's got to be a multi-zone system. What most people do is that there's a range of audio splitters out now which you can attach to the output of an amplifier, and it'll give you multiple protected transmission paths out of that one amplifier. So we're not talking about multi-zone systems. It's still only a single zone system in the main, where the evacuation signal is generated to the whole building simultaneously. There was also a clarification to what could be lost on a smoke control system. So now you can lose the control of one fan of a supply or exhaust fan, and the indication and controls to stop and start the fan could be lost, but you would need to put fault isolators in so the next fan would be protected. And similarly, if you have output devices on a transmission path, and they don't form part of the occupant warning or the smoke control system, then they would need to be separately protected as well. So if you had multiples, you would need to use short circuit isolators and a fault tolerant loop, fault tolerant transition path. So short circuit isolators are now known as transmission path isolators to clarify their usage, I guess. And 1670 doesn't really have any specific requirements on the use of transmission path isolators. So the designer must decide on their application and when they're required to meet the requirements of clause 2.6. And there's a standard transmission path isolators, which is part 17. That's been referenced in the last two editions. So there's several versions of transmission path isolators. They could be standalone modules. They're frequently incorporated in detector bases, and increasingly we're seeing that they're actually inbuilt into other devices such as detectors, audible alarm devices and visual alarm devices, and input-output modules. So we'll just go through some examples of the use of short-circuit isolators. So, and where you would need to install them. So we'll just concentrate on this simple detector circuit that we have here. So we've got a transmission path which comes out of the FDCIE and loops around through zone 1 and then goes to zone 2. So because there is 2 zones on the transmission path, because this transmission path returns to the FDCIE, it would need to be fault tolerant. It couldn't be an open transmission path, and we need to put short circuit isolators between each zone. So these black circles with the X on them signify a transmission path isolator. So you would need one between each zone. So if I get a short in zone 3, the transmission path isolator here and here would open, and the zone would continue, the remainder of the points would continue to operate at the panel. There's no short circuit isolator shown between this first detector and the panel, because we're assuming that the panel would have a short circuit isolator, a transmission path isolator built into it, and similarly on the return leg. So, and of course, so the transmission path isolator could also be incorporated into one of the smoke detectors. So this transmission path isolator could be either a short circuit transmission path isolator mounted under this detector, or it could be built into this detector or this detector here. It doesn't need to be a separate unit, as we've said before. So on a detection circuit, that's how you would achieve the transmission path isolators to cover short circuits. The open circuit would be covered by the fact that it's a return redundant loop in any case. So the short circuit transmission path isolator would only operate when there was a short on the actual transmission path itself. I won't go through the rest of them, but you know, as you go through it, you can see that we have a transmission path isolator between the supply air detectors, because they're separate zones. So if there's a short on the transmission path feeding one of them, that would need to open and enable the other to continue operating, because I'm only allowed to lose one detector or one zone. Similarly, we have requirements for power supply as well. This is an array of VESDA detectors of ASD, aspirated smoke detectors, connected as various zones. The alarm indication is provided by the VESDA net, the red cable, and this would be protected by there being transmission path isolators inside the ASD units themselves. So if I get a short circuit on the data, then the short circuit isolators would open and all the devices would continue to operate. The thing that's not clearly understood is that these are shown in a daisy chain for power from the power supply to feed the units. And this would present a problem because if I got a short circuit on the power supply, I would blow the fuse probably, but I would lose power to all of these ASD, which means I would lose 6 or 7 zones simultaneously. And the requirement is that a fault can only affect one zone. So the only satisfactory way to do it, the data would not have to change because the data already meets the requirement. But what I would need to do, I can use a common power supply, but a separate power feed would need to be run to each zone. So you can see that zones 1 to 6 require separate feeds. Zone 1, it's slightly obscured in my thing. Zone 1 can have a common feed to these two ASD because they're both connected to the same zone. So if I lose power, it's acceptable to lose both of those ASD because they're both on the same zone. But all the others that are on single zones all need separate power feeds. And that's something that's not clearly understood, but is a definite requirement of the standard now. So that's an acceptable way to do this. Similarly, for audio, the requirement is that I can't lose more than one level or 2,000 square metres. So this is actually showing us an example where we're using splitters out in the field to give us one transmission path feeding the SOU common SOUs, and another. This is a typical sort of apartment block, if you like. Another feeding the common areas within the apartment block. Now, this appears to be very nice, but the problem that it has is that it uses both common audio and common power. So if we had it wouldn't be acceptable, because if we had if we had an open here, we would lose audio to 2 levels. And if we had an open or a short on the power, a similar thing would happen. So the only acceptable way to really do audio is to put the splitters at the FDCIE. It's very, very difficult to put audio splitters out in the field, because if you're going to do that, you need either separate power feeds to each of them, and you need separate audio to each of them, which really would defeats the purpose of using the splitter in the first place. And similarly, if I have a an audio splitter on a single level in a warehouse, because the current limitation is that I can only lose 2,000 square metres maximum. If I've got a 4,000 square metre warehouse, I could put 2 feeds in, but in this particular case, it's been designed to around 3 feeds. But once again, the audio splitter is at the FDCIE or the EWCIE. There is a variation to this which is being proposed in Amendment 1 to 1670. There's an amendment coming out with a number of changes in it, and there's an exemption that where you have an open area, you can increase the 2,000 square metre area to 4,000 square metres, provided it's one open area. So you couldn't put the 4,000 square metres would not include an office admin area, because it's not part of one single compartment. So if you've got one single compartment, you can increase the area to 4,000. So in that case, using that exemption, you would still need one transmission path in the office area, but rather than splitting the 3,000 square metre, you could put this on one transmission path. And that is due to be published in the next month or so. But once again, it would only apply to areas such as car parks, warehouses, big bulk storage sale places like Bunnings or something like that, So that's an acceptable way to install the splitter. Oops, sorry. So the next thing we'll look at is networks in 1670. Prior to 2015, networks really weren't terribly well covered, and exactly what a network was almost determined by a manufacturer rather than the actual installation standard. So there was a definition for networking, and this was defined as the transmission of information and power from an FDCIE to another FDCIE. So it was it was definitely limited to the connection between what was previously known as fire indicator panels. And the requirements for transmission paths, whether they were data, high level data, or whether they were simple analog connections with the main, say the one FDCIE being connected to a main FDCIE to call the fire brigade, such as you have in a school campus or something like that, where there was an FDCIE in the physics building and it was connected to a main FDCIE in the main admin building that then called the fire brigade. The same requirements applied whether that was via a high level data or whether it was simply a connection through the main alarm relay on the physics building FDCIE connected to a zone on the main FDCIE in the admin building. And we also set to clarify some sort of relatively important control functions which actually can affect how networks operate. So clause 2.4 was really written to set out a number of requirements on networks, and some of the important changes. The first is in B here, which says that a fire alarm condition on an FDCIE shall be indicated at the main FDCIE or at an FDCIE or any other FDCIE where it was required. So if there are other FDC on the network that I wanted to indicate that alarm on, that needed to be indicated within 10 seconds of the alarm occurring on the FDCIE. So if I had, once again, an FDCIE in the physics building, when an alarm occurred on the FDCIE in the physics building, it needed to be enunciated on the main FDCIE within 10 seconds. And surprisingly, there was never a time requirement contained in 1670 previously. So there are some sites around Australia that are fairly notorious because it can take up to 30 or 40 seconds for the alarm to transfer from the FDCIE to the main FDCIE. And that was obviously, unacceptable because there was no time requirement contained within 1670. It was actually allowable. And when you consider that there's a time constraint of 15 seconds for it to go from the main FDCIE to the fire brigade, the 10-second requirement is not extremely onerous. And it is a little confusing because there's a manufacturer who's just proudly announced that, that his panel can do this within 20 seconds. So I'm not sure whether he'll be able to install networked FDCIE within Australia. But the time requirement is 10 seconds. And it's 100 seconds on for a fault, which is not considered to be a critical issue, and that really aligns with the standard ISO requirements. So the other requirement, which is really a tidy up of what was already in there, was that on any site, not more than 2 FBP need to be interrogated to determine the detection zone in alarm. So the requirement within 1670 now is that the only way information can be presented to the emergency service personnel attending an alarm is via a fire brigade panel, because that's the agreed alarm control and display enunciator, which is required by the fire brigade. So if I have a panel that's networked to a main FDCIE and it only transmits a master alarm rather than it's a low level alarm rather than high level data information, then the fire brigade goes to the main FDCIE. It tells them there's an alarm on the physics building. They go to the physics building FDCIE and they can determine the alarm, but they can't be required to go to 2 places, so alarms can't daisy chain through a line of panels. Another change, which is probably significant for some manufacturers, and it was really meant to set people thinking about how networks are configured, is that if an alarm occurs on an FDCIE, so there's an alarm in the physics building, and it generates an alarm on the main FDCIE, the only places that alarm can be reset or disabled, and disabled is important because in some situations, disabling an alarm on an FDCIE will actually reset the alarms. So the only place it can actually be controlled, that alarm can be controlled, is either at the main FDCIE or from the FDCIE in which the alarm condition was initiated, which of course would be the physics building. So if I had elected to enunciate that alarm on a number of other fire panels in other buildings, those fire panels, those FDCIE could see the alarm, but there's no control that can be, so the alarm can't be reset or disabled from other panels. And the implication there is that a lot of people's networks, if the alarm is initiated on an FDCIE, then you can automatically reset or disable the alarm at that FDCIE, and you're no longer able to do that. And I guess the thinking here is that people, rather than deciding that I've got all these network panels and I'll enunciate an alarm on every one of them, is it sort of necessary to do that? Because if I can't exert any control over the alarm at a particular FDCIE, and I'm not expecting anyone to respond to the alarm from that FDCIE, is it even necessary to enunciate the alarm there? So it sort of oversees out that, you know, the common practice is in many instances is slightly different to Australia. So we're suggesting that maybe, you know, we need to think more closely about how we actually configure our networks. So we've just got a couple of practical examples here. You know, building A contains the main FDCIE. Building B contains an FDCIE which is networked via transmission paths back to the main FDCIE. I'm not sure whether everyone can work out why we've got a redundant connection here. We've got redundant transmission paths. Obviously the reason is this is a 3-story building, so there must be at least 3 zones in this building. So this FDCIE has 3 zones, so we require a redundant connection. The transmission path has to be redundant. And of course there's no transmission path isolators shown because they would normally be built into the equipment. Within the standard, there is now a distinction between networked FDCIE, which we just looked at, and distributed CIE. So these 2 FDCIE are not connected together, they're not networked, but we do have distributed CIE within building A. So they're shown with blank boxes because the fire brigade are not expected to attend these. They would simply come to the FDCIE to determine where the alarm is, and this distributed CIE wouldn't require their attendance. They might be additional loop cards. Instead of putting, you know, 20 loops down here, we might have 10 loops here and then 5 at each of these CIE, but they're not FDCIE. However, we're assuming in this thing, we've assumed that each of these CIE have more than one zone connected to them, so they require connection via a fault-tolerant transmission path back to the FDCIE. So if we had a short or an open on the connection I'm pointing to here, everything would continue as normal because this FDCIE would talk over this transmission path, and the FDCIE, or the CIE on the first floor would talk on this transmission path. And of course, if we decided that we were going to interconnect all of these things via this transmission path, because these things are networked, but the connection between them isn't necessarily considered to be a network. It's a transmission path. So we've got a fault-tolerant transmission path connecting all of this equipment. So once again, we meet the requirements of 2.6, because if we cut or short any of these transmission paths, we probably wouldn't lose even a single zone, because everything would continue to operate normally. What we'd have is a transmission path fault at the panel, telling us that one of the connections wasn't operating correctly. So the last thing I'm going to deal with is remote access, and this is I guess a complex and developing issue, because the number of devices which are available to give you access into a fire detection alarm system, an FDAS, has really expanded fairly dramatically in recent times, and it's probably not adequately addressed even by the 2018 edition. But one of the big changes in 2018 was a new clause, connected with devices, was added. And this was added to cover the control of an FDAS by things such as graphics packages, such as Honeywell's OnyxWorks, or building management systems such as Honeywell's EBI. I mean, other people have their own versions of these things. And a key change was that a connectable device could now control a fire alarm system. So rather than simply a fire alarm system being able to transmit alarms and faults to a building management system, now a building management system under some strictly controlled circumstances is permitted to exert control over the fire alarm system. So it's possible to do reset, isolates, disablements, that type of thing from a building management system. The key change is that a building management system, that the fire alarm FDAS can't rely on the operation of the building management system. So if the building management system falls over, the FDAS still must perform all of the essential functions. So the connectable device becomes an add-on device which might make the operation of the system simpler and easier, but if the graphics package fell over, then the FDAS would continue to operate normally. But the clause didn't really deal specifically with remote access, other than where you did reprogramming of the FDCIE. So it kind of didn't really cover the control through PC or tablets or even mobile phones using the internet, and they were things which a lot of the larger manufacturers are really starting to offer these features already. So the main, as I said a minute ago, the main things were that connectable devices, the operation can't be reliant on the connectable device, and where you're using one of these, you had to meet some conditions, so the failure of the connectable device wouldn't really affect the operation of the FDAS. So, for example, if I was using a graphics package or something in my guardhouse or fire control room, I'd still need to have an FBP, a fire brigade panel, accessible. So if the monitor or something failed, I could go to the fire alarm panel, which is readily accessible, and control it through the traditional means. And all the transmission path connections and everything else had to be in accordance with the ACMA requirements, and the connectability or the compatibility included of the connectable device with the FDCIE had to be assessed, and that could be assessed using 7240 Part 13. And the only real clause which limited remote access was that the connectable device shall not have remote access to access levels 3 and 4 functions, which is set out in 7240 Part 2, which is the FDCIE standard, without these having been manually enabled at access level 3 and 4 directly at the FDCIE. So that was really meant to say, well, if I wanted to change the configuration of my FDCIE, and I was doing that remotely from, say, the Honeywell office in Baulkham Hills, then I would need to have someone on site, presumably the fire contractor who was getting me to do this, would be on site, and he would verify the access level 3 or 4 at the FDCIE. So I couldn't simply, be in my office and dial into a panel and change the configuration. But it didn't deal specifically with whether I could do resets and disablements and that sort of thing remotely. So the remote access thing really probably caused the most angst, because in the FDCIE standard, the access level for achieving resets, disablements and silencing is done at access level 2, not access level 3 and 4. So in the current edition, remote control is not specifically prohibited, but certainly the clause, this was meant to be, was not meant to be done. And it sort of is covered by a fire alarm condition on an FDCIE shall only be reset or disabled from the main FDCIE or from the FDCIE in which the fire alarm condition was initiated. So that wouldn't normally be if I was remote from the site, because I'm not considered to be at either of these FDCIEs, so I shouldn't be doing that. But this has been clarified, and at the insistence of the fire brigades. So there's an amendment to 1670, amendment number 1 to 1670 Part 1, 2018, which will be published later this month, and it will prohibit the resetting, disablement or silencing when you have remote access. So that pretty well finishes my presentation, and I assume we've got a number of questions here now. Which I'll answer. We've got from David Gadsby's asked me, what is the clause for the 4,000 square metre exemption? That will be contained in the amendment, which I haven't got right to hand, David, but it's given as a note underneath the existing clause. So it says something like where there's an open area that's one open area, the 2,000 square metres in the above clause can be expanded to 4,000 square metres. But it's definitely in there, and it has been agreed to in public comment, so it will be changed. But as I said, it won't be published for the next week or two. But it should come out. It should come out by the end of September. Sophie's son, would we meet 2 of dry risers in different locations for transmission paths? The separation requirement for transmission paths has been varied slightly, so it really depends on whether the anticipation is that both transmission paths could be affected by a single event. So if you had them in a single riser, and they were fixed in ducts or on a cable tray, and a foreseeable event could not take out both risers both transmission paths at the same time, then it would be acceptable to put them in the same riser. You wouldn't need to go up a vertical riser on one side of a building, run across the floor and go down another riser. They could be in the same riser. So it really comes down to whether a single event would affect both transmission paths. I hope that's what you're referring to, Sophie. I'm not really sure. There's another one from Nathan. When will duct probes have isolation modules in them? Well, I'm not really sure. I think some brands may well have. As I said, there's no real requirement for a manufacturer to provide those. So I guess it's a matter of what particular manufacturers decide to do. And increasingly, input-output modules are being supplied with isolation modules in them. But once again, that's more a factor of what a particular manufacturer decides is best from a marketing point of view. There's no requirement in the standard for that to be done. There's a question here. Does that mean, as per standards, one can't reset, isolate, and silence? Isolate's the same as disable, and silence panels remotely away from the facility. Well, that is not clearly the requirement now, but in Amendment number 1, that is one of the things that's covered. There's a remote, a definition for what remote access really is, and remote access is considered to be access which is gained from outside a facility. So, the thing is specifically meant to ensure that I'm a building manager. 1 o'clock in the morning, my phone goes off and tells me there's an alarm on the fire panel in one of my buildings. I can be advised of that via my mobile phone, but I can't go into an app and control the panel. That needs to be done on site. So that's been clarified much more adequately in the new amendment number 1 to the standard, because there was some confusion over what the actual requirement was in the existing standard. And I guess it's also the changes in remote access and how that works is really also designed to cover things like Honeywell's CLSS, which is where we can actually communicate. Someone can be servicing and testing an FDCIE, FDAS via a mobile phone without having to go back and reset test alarms and that sort of thing from the panel. So there needs to be an element of control over what's acceptable to do on site in that sort of situation. But you wouldn't want to be able to go, as I said, go back to the office and exert the same level of control over the system through the internet. That wouldn't be acceptable. Oh, there's a thing here. Can you explain the access levels referred to in the remote access slide? Yeah, 7240 ISO has a variety of access levels. So access level 1 is considered to be someone can walk up to an FDCIE and determine the alarms that are present on what alarms are present on the FDCIE to enable them to go and investigate that, and they could silence the actual buzzer on the FDCIE to stop it from squealing, but they can't exert any other user access. Access level 2 is via an entry code or a say a 003 key, which would then give a user, someone such as the fire brigade responding to an alarm, the ability to reset the alarm, disable the alarm, or silence the warning system and that type of thing. But they couldn't actually do any reconfiguration, so that they're the sort of standard user type access levels. And then access level 3 enables you to go in and actually change the configuration, so you could rename zones or change a smoke detector to a heat detector, or do some simple programming changes that relate to the configuration. And access level 4 is a higher level access that allows you to actually reconfigure, to upgrade software, or to make some major changes to the system. So it's intended to limit the access which various users can have in a predefined way. Another question, the connectable device clause seems to allow a BMS system to control a fire system. Isn't this prohibited? Well, as I've already explained previously, the only connection between an FDAS or the fire panel FDCIE to a BMS system was reporting of alarms and faults and the ability to do a simple test. But now full control is permitted, provided the system can still operate correctly if the connection to the BMS system was lost, or the BMS system failed to operate. What happens if a manufacturer can't meet the 10-second alarm transmission requirement? Well, I guess the 10-second is something which needs to be done on each installation, because under some circumstances, depending on the transmission time of the alarm from an FDCIE to other FDCIE or to the main FDCIE will depend on a lot of different things. It may be whether the type of connection, whether it's across a wide connection or whether it's fibre optic, whether the manufacturer is using high-speed or low-speed modems. And of course, it could vary from site to site depending on the type of installation. For example, road tunnels and that sort of thing, and train tunnels, they tend to have a large number of networked FDCIE connected to them. But because there's no there's frequently a very limited number of analog smoke detectors connected to the loop. There's very little information that's being transmitted from one FDCIE to another, so the actual connection on the transmit, the information on the transmission paths isn't really overloading it, and that can have an effect on the time for a signal to be transmitted. So the 10-second is not something that can really be done at a laboratory. It really needs to be done as part of the commissioning on site to ensure that that particular installation can meet the standard. Another question, does an audio splitter give me more zones? No, it doesn't. The purpose of the audio splitter is to give you additional supervised transmission paths on a single amplifier. So typically on a 1670.1 occupant warning system, you've got an amplifier, and it's typically feeding out a 100 volt output. You can connect that single 100 volt output onto an audio splitter, which will then be divided. And I think the majority of audio splitters probably are in groups of 4. So it will feed the same signal out to 4 supervised transmission paths. So it doesn't increase the number of zones. You've still only got a single zone system, and all of the transmission paths will operate at the same time. So just any new questions? There's a question here. Can you please confirm if remote access for a major facility with multiple separate buildings will mean that disablements cannot be completed over a separate graphics package? So if the graphics package was, the graphics package would normally be connected to what would be considered to be the main FDCIE. So it would be, working. It would really be treated as another FBP location, if you like. So because the new restriction is that you can only reset or disable alarms, then it would be acceptable under non-alarm conditions to go into any FDC, from the graphics package to go into any FDCIE that was connected to the graphics package and disable a point. So that would probably be acceptable. Under alarm conditions, it would be acceptable to disable or to reset an alarm on the graphics package, because that would be considered to be the same as resetting it at the main FDCIE. But if the graphics package was not contained within the facility, then it certainly shouldn't be able to do that. If it was at another site, it would not be able to do that with the new amendment, and it's not intended to really do it in the existing standard, although it may not be adequately described. But in real terms, the connectable device clause was meant to say that something like a graphics package, if it was in the fire control room or some security centre, which was designed to control alarms during a fire event, then it would be acceptable to control the system through the graphics package. I think that's really the last question because we're right on the hour now. I think that's really the last question which we're able to handle. So I'll hand back to the lovely Carol to wrap up now,
Thanks,
if you
Keith.
like. Thank you, Carol.
Thanks, Keith. That was really informative. Yeah, I have a lot of questions here, but unfortunately, we're really running out of time. Yeah, there was also a question asked Keith, the nice golf club at the back, but yeah, so to get a question
I'm too
answered.
busy to use them, unfortunately.
I'm sure in the lockdown we couldn't find out. But there was a button here called book the meeting. So if your question hasn't been answered, please leave your question here.
Yeah, I'm sorry, but we'd be here for another half an hour. There's probably about another 10 or 15 questions to answer.
That's right. Yeah, so there's a way to reach out to us directly. If you just click that button, and they will come back to Keith with your questions. And if you want to book a meeting with him, like private meeting, please use that feature as well. What do you think of this webinar? So we'd like to hear from you. We have also prepared a short survey just to help us to understand what you'd like to hear from us, what specific topic that you want to discuss with Keith. So please let us know. Thanks for that. And next webinar we have available for next week, next Thursday, 11 o'clock, is Your Warehouse Protect Against Fire Risk, Detection Design for Warehouse and Open Spaces. And we're looking forward to seeing you there as well. That concludes our webinar today. And thank you, Keith, again. Thanks so much for your education sessions. And thank you very much, everyone. Have a nice day.
Yeah, thank you all for attending. Bye now.
Thank you. Bye.